Drink my coffee a few times.
Hey there, people. Chargers, it's Mrs. Boyd here talking today about systems of inequalities. It's going to be your favorite graphing. We can totally do it. Don't despair. So what I want you to focus on is graphing each inequality separately. So first, we're going to do this top inequality. Y is greater than or equal to negative x plus 2. So y-intercept is 2. So we go up 2 on the y-axis, and that's our first point. Slope is negative 1, that number in front of x. So from our point here at positive 2, we go down 1, right 1, and that's our next point. And then we can keep doing that. The equals sign in our inequality means this is going to be a solid line. And because it says greater than, we're going to shade above it. So that's the first line. Second line, y less than 2x minus 2. So the y-intercept is negative 2. And the slope's positive 2. So up 2, right 1, up 2, right 1. No equals in our inequality, so this is a dashed line. And it's less than, so we shade below. Now the solution here is right here, where our two solution zones overlap. So what we need to do are put 3 solution points from this area as possible solutions. So we could have right here, 4, 0 could be a solution. How about 5, 2? And how about 3, 1? Those are all possible solutions. They all fall within this area here. Let's do another one. All right, we've got x is greater than negative 1. We find negative 1 on the x-axis. No matter what y is, x is negative 1. That means this is a vertical line at negative 1. Remember, we talked about making this a table of values, and x is always negative 1, and y is whatever it wants to be. So negative 1, 0, and negative 1, 1 are all on the same line here. We could even do negative 1, 2. So this has no equals in our inequality, so it's a dashed line. And it's greater than, so we shade above, or in this case, to the right. The numbers that are greater than negative 1 are to the right. Let's do this next inequality. Y is less than or equal to negative 3. Well, this is the same idea. We make a table of values, but negative 3 are all the y values now, and x can be whatever we want them to be. So 0, negative 3 is right here. Negative 1, negative 3, and 1, negative 3 are all those points. The equals under our inequality means that we've got a solid line. And the less than means we shade below. Now we want to list some possible points in our solution zone. We could say 0, negative 4. We could say that, let's say 1, negative 3 is a solution. We can say that because the y less than or equal to negative 3 line is solid. So points along that line count in our solution set. We could also say 4, negative 5 is our possible solution. All right, a couple more on the front. See if you can do these on your own. Okay, first we've got y less than or equal to negative x minus 1. Negative 1's our y-intercept, so we go down 1. The slope is negative 1, so down 1, right 1. There's an equals in our inequality, so it means we've got a solid line. It's less than, so we shade below. Next inequality. If I can get my computer to cooperate. There we go. Y is greater than or equal to negative x plus 3. So we go to the y-intercept of 3. 1, 2, 3. Slopes negative 1. Down 1, right 1. Down 1, right 1. Solid line again. It's greater than, so we shade above. Well, these lines are never going to cross. They're parallel lines. So this is going to have no solution. These shaded areas will never intersect. Let's do another one. Y is greater than 1/2 x minus 3. So our y-intercept's negative 3. And our slope's 1/2. 1, up 1, right 2. Up 1, right 2. It's a dashed line because there's no equals in our inequality. And it's greater than, so we're going to shade above. Next, we've got y is greater than or equal to 1/2 x plus 1. So our y-intercept is positive 1, and the slope's 1/2. Up 1, right 2. Up 1, right 2. This is a solid line because it has an equals in it. Possible, and it's greater than as well, so it's going to be everything up here. So possible solutions would be 0, 1. Would also be 2, 2. Or 0, oh, nope, just kidding. How about negative 3, 0? Those are all solutions for that system of inequalities. All right, let's do some word type problems. Autumn sells a box of pasta for $2 each and jars of sauce for $3 each. Autumn needs to make at least $12, but has no more than 8 boxes and cans combined. Let's first set our variables. We're let x be the number of boxes. And we're going to let y be the number of jars. So inequalities. We have one of those, 2 of each kind of jars of sauce for $3 each. $2 for boxes of pasta, $3 for jars of sauce. She needs to make at least $12. So that means this combination has to be greater than or equal to 12. She also has no more than 8 boxes and cans combined. So that means x plus y, we add those together, has to be less than or equal to 8. She has to have less than those combined together in her solution here. All right, let's graph what we've got. We can find intercepts first. How about that? We can make this top yellow equation 2x equals 12. That means x is 6 when y is 0. So we go over to the 6 on the x-axis. 1, 2, 3, 4, 5, 6. And that's 1 point. We find the y-intercept, and we have 3y equals 12. That means y is 4, so we go to 4 on the y-axis. There's an equals in our inequality. Oh, that was bad. So it's a solid line, and it's greater than, so we shade above. Same thing with x plus y is less than or equal to 8. We make x equal 8 and put a dot right here. And we also have y equals 8 and a dot right here. Oh, that line's awful. Don't judge me. This one is less than, so we shade below. And where our shadings overlap is where the solution lies. So possible solution for these, how about 3, 4? That means she has 3 boxes of pasta and 4 jars of sauce. You add those together and they're less than 8, and the cost is going to be more than $12. Let's try this bottom problem and then we'll call it a day. Nathan makes $10 an hour delivering pizzas and $5 an hour babysitting his sister. He wants to make at least $40, and his mom said he has to work for less than 6 hours a week. So we can tell from here what our two variables should be. In this case, we're going to let, not that. We'll have X equal hours delivering pizza. And we'll have Y be hours babysitting. So one equation will be $10 an hour delivering pizzas and $5 an hour babysitting his sister. And he has to make at least $40. So that means that has to be greater than or equal to 40. The other thing we know is that his mom said he has to work less than 6 hours a week. So that means X plus Y has to be less than 6. Let's graph these puppies. We know that we can use the intercepts to find these values. So say 10X is 40. If we get rid of the Y part, that means X is 4. For our X-intercept, Y-intercept, we have 5Y equals 40. That means Y is 8. 1, 2, 3, 4, 5, 6, 7, 8. This is a solid line because it has an equals and the inequality, and it's greater than, so we're going to shade to the right. Now, the other one, our intercepts are 6. 1, 2, 3, 4, 5, 6, and 6. This is a dashed line. Oh, it's so curvy, so sorry. And it's less than, so we shade below. So possible solutions here. I'm going to say one possible solution is 3-2. So 3 hours delivering pizza and 2 hours babysitting. All right, folks, we're going to do more of this. Don't despair. It's tough, but I know you can do it. Let me know if you have any questions. I'm sure you do, and I'll talk to you soon.